All right, good afternoon. Good to see you back here. Second lecture. It's still smart cities. Many known faces, a few new ones. Danielle already said that this sheet that is going around, please do sign it because that's part of the presence that you have to show in order to pass the course, plus the 3 assignments, the 3 exercises. So I'm sorry I forgot to mention that last time. Today, we start with urban systems. And Danielle Grego, our assistant, told me that it was probably a bit too abstract or too high, lofty what I told you about last time. So I tried to come down a little bit and start from a smaller scale. Maybe then we can work our way into the urban systems this way. So we are here on the number 2, urban systems. And today we want to do a definition, a more formal definition, but also a more understandable definition of smart cities. The story so far, this will happen now in every lecture. You have to look at the second from the top always. This is what happened in the last lecture. So last week we talked about cities and that they are complex systems. And ideally, they are sustainable, resilient, livable, smart, and finally responsive. So these are the steps that we want to arrive at. And they should develop, if they're not already there, from being just production machines or places where people come together to do certain tasks into a real human habitat. So this is our challenge for the future, and smart cities are an important step in this development. And today, this is on the top, we want to start with the explanation from smart houses to smart cities and to give you the emerging criteria for smart cities as urban systems. But we can start even one step back under smart houses. That would be what? Yeah? Smart room, yes. So do you think we are in a smart room here now? Yes? So what's smart about it? Yeah?
It's connected or interconnected. It has many elements that are connected to each other.
Yeah. So what, for example,
Sensor.
the sensors, yeah, there are sensors for the light, that's right.
Also, this big video again.
Yeah, but this is totally manually controlled.
Okay.
Fortunately.
Okay.
But that's a good idea. We could link that up to certain moods also in the space here so that it goes faster or slower to wake you up or to calm you down. That would be possible, right? So what else do we have in terms of smartness? Have you noticed when you came in, the door was open? Do you know what happens when a door is opened? This is part of the smart systems that you don't see, which is sitting underneath the floor, which is the air supply. So as soon as you open any door, the air supply is shut off so that you don't heat the air outside. So that's also done with a simple sensor. And Danielle Grego, as part of her PhD research, is looking into how much more smart elements we can find or should define for this building. And so this is, I think, understandable how smart it could be. It also has, some of the spaces have CO2 sensors. So that means when we are thinking too hard, and there's so much CO2 coming up, then the air should start to circulate. In the old days, how would you have done that? Open the window, right. So that's an interesting point because who knows what is really smarter, to open the window or to start this whole air conditioning system here? Not air conditioning, just air ventilation system here. What has a better effect, a more direct effect? And that shows the whole question of smartness and its effect on the human. And this question, should we do something simple? Just open the window? Or should we run the whole system? Will just accompany us the whole semester, as you will see. Almost at every step we have to answer this. just an aside, did anyone watch the moon last night? The eclipse of the moon?
Just pictures.
Yeah, that was quite incredible. That's why I'm a bit tired. So that was the story so far. And today, as we said, from smart rooms, now we go to smart houses. We look a bit deeper into this. But before that, two things. If you remember last time, there were two things on the first lecture that I did not talk about much. I just want to very briefly tell you about it, because you can all read it in that Information Cities book that I gave to you. But I promised to talk something about information architecture, what it is, because that's the name of the chair. And this information architecture has two meanings. The one meaning is information architecture with capital architecture, to make the invisible visible in architecture, in urban design, and in territorial planning. To make the invisible visible would be, for example, do you hear that noise in the back? You cannot see it, right? But you can hear it. So in information architecture, you would make that visible as a curve or as a volume or whatever. That's an example. And the other meaning of information architecture is, with capital information, to use the metaphor of architecture for the structuring of big data. Big data, it's called today. Before it was called the huge, or data in the life sciences, huge masses of data for which we can use the metaphor of architecture, the abstractions of architecture, to bring some order into this data. In this book on information cities, it's described like this. It's the same description, but that brought me to the moon, because does somebody know this, this setup here? Somebody here from India? Yeah, you must know it. Remember how it's called?
I don't know. I know it's in Delhi and it's the oldest clock. Yeah?
It's in Delhi. It's a Jantar Mantar, and with this Jantar Mantar, they should have been able to predict the here in this building. The two meanings of information architecture come together. On one hand, all this data that the people at this time in the 17th century knew already about the sky and the movement of the planets. That's their big data at this time. And on the other side, to make the invisible visible, that means to show that we have information on this and to actually build it. And that's what we call information architecture, everything in capital letters. These are buildings which are exclusively made for information. Do you have any other buildings of this type today? Do you know of any buildings today? They are really made for information, that contain information, and that are also an expression of information.
Buildings for big telescopes.
Big telescope, yeah, exactly. So they are really, they only look like this because they have to follow this task of observing the skies. And today, of course, the telescopes look different than at this type. Also look different from 100 years ago. And they could be actually whole clusters of telescopes, like the new ones in the Atacama Desert that they're building now. Yeah, so these are the two meanings of information architecture, and the third meaning if you have buildings that are made for this, or big data centers and places like this. Whole new class of architecture. Okay, that was the one expression, and the other one was urban simulation. Urban simulation, we will revisit this expression too, but this is out also from the book. So the city simulation is a part of simulation, of course, and simulation is defined as the imitation of the operation of a real-world process or system over time. In science, simulation is becoming very, very important, or has been important a long time, next to experiment and also theory. And in architecture, it's also been used for decades already, but not as much as in many other sciences or in engineering. But now in architecture, in urban planning in particular, urban simulation will become much, much more important. And next lecture, next week, when you hear about the methods and instruments of simulating and modeling cities, that's when you have to come back to this definition. And in our context here, urban simulation goes a step further because we want to connect directly big data to urban simulation. And that's something specific that you will probably not find in the traditional definitions of urban simulation. If we connect it to big data, when we look at the development of the data, this line here being the line between the present and the future. So the present and the past is here, and the future is here. So the amount of data that we collect over time is getting higher and higher and higher and higher. So here we have a huge wall of data. This is the wall of evidence, as we call it. And beyond this evidence, some people get so totally stuck in this evidence and analysis and analytics that they cannot think into the future because everything seems to be just measurable but not designable for the future. And this is where design comes in. Design can happen in any discipline, in any science, if you want, in architecture, in engineering, but also in computer science, design of something new, which places an idea out in the future, beyond the separation between the past and the future. And then the simulation, you can try, if you can build a bridge from the present into this future situation. So anyone who's doing a building design, when you do building design, of course you know many things from the past if you had an education and you have a purpose and a function and so on. But when you draw this building or you model this building with a computer, normally it has never been there before. So it's something really out there. That's interesting because then you have to convince your clients that this is a good thing. And in order to convince your clients, you often use simulation to make sure that she or he knows that this is really a good thing to do. All right, so this was our short excursion. And these are some of the foundations that we need for this course. And as I said, if you're interested, you can look it up in this Information Cities book. Now let's move into the definition of smart cities and compare first houses and smart houses. Because a few years ago, of course, there were no smart houses. This is an invention of maybe the last 20, 30 years that there are smart houses. And next to the very technical definitions that you will get in the literature that we give you and that you will hear in conferences and so on, it's my intention to always remind you where it's coming from. Houses originally came from an analog world. They were not a digital design. They came from an analog world. And so in this analog world of architecture, of course, architecture is the most important thing. And the first houses were architecture. So they were literally making architecture shelter. So the security was a big issue. Then came convenience to make it more comfortable. Then later in the 18th, 19th, 20th century, performance became an issue. How much does it cost? How can you heat it? And so on. And finally, just quite recently, control comes in, control of some kind. The old control is, of course, well, what's a typical control for a building, let's say, of the 18th century? Door lock, yeah. That was basically the control you had. And you had maybe a bridge, a drawbridge, but that was about it. Thick walls, and so that was it. But this has, of course, become much more sophisticated now. So if we move to the digital age, which we are in since maybe 30, 40 years, increasingly. And the digital age, of course, developed not only because of architecture, developed because of the whole society, especially industry and IT industry. And of course, for IT industry to survive and to develop new products, they must bring that to the customers. And there, I would say, just from reading the advertisements and reading about architecture, somehow the order has shifted. So suddenly, smart houses, if you read and you will see some examples soon. Convenience is a very strong word first. You know, it's convenient. Everything's easy. Secure. Everything is very secure. You have control, total control. You have total performance. You have pay almost nothing. Everything will go by itself. And architecture almost disappears. And this is a shift that has occurred. Of course, we are in the architecture department, and so we see that in a different view, and that's why I put this old view here. And the old view, I think over time, these different criteria will change their place in their order again. Now, here's an example, and maybe you can guess where this building would be if you just look at the different sensors and pieces that are important for this building. So you see, it's not very focused, unfortunately, but you have this object that is supposed to express some form of architecture, I suppose, or a building. So a very important part, you have a home server. Home server you wouldn't have had 20, 30, 40 years ago. It didn't exist. TV sets, yes, you would have had this, but of course the TV set is somehow connected to the home server. You have a SOS button, so that is for security or safety. You have a master panel. This is where you yourself can control things or think you can control things in the house. So that is the control level. You have camera, also to look to the outside and to the inside to protect you. You have wind and rain sensors on the outside. You have air conditioner, not here, so that already tells you where that building might be. You have light switches, that's old, had a long time. You have sockets for electricity, you had that for a long time. You have infrared cameras, relatively new. You have smoke sensors. You have gas leak sensors. That means it must be in a region or in a place where you have gas in the house, which is less and less the case. You have so-called smart windows. What is that, smart windows? As you will see, they are not so smart. They're just doing things that you tell them to do. You have light switches, you have body sensors, you have video door phone system, and you have door magnet sensors. So these are all typical things that you can buy in the supermarket today to make your home in a so-called smart home. Yes?
What is the point of putting all that in a house? Is there an interest further than just the company's interest? Because if I recall, the definition you gave of smart cities was, the first thing was like to diminish the use of resources. When I see this, I feel like the resources needed to produce all those things are actually probably higher than the resources we're gonna save. I mean, if I take the 3.9 inches master panel, how can that help me save resources?
Yes. Yes. Okay. So maybe I have been too, how should I say, subversive in describing it to you like this. There is a large degree of truth what you said, but I would say it's only because there is an absence of something more understandable that we as architects or we as city planners have to produce to counterbalance or to make this into something useful. Where you're absolutely right is that all of these measurements are typically used in cities or in buildings that are totally unsustainable. They are made at a very high level of luxury, and then these things are supposed to help you bring down a little bit use of energy and other things. But it's a very true observation, but that is one of the challenges, the first exercise. You find out yourself, what is the definition of a smart city for you? So you can, you're all free. But I want to show you at least what is there today, as it is seen. So this is one definition, and you saw this is from the UK Department of Trade and Industry. So it's not a commercial company. Yeah, yeah. And then here we have another one. This just also from Tahoma. This is from Somfy from Switzerland. Machen Sie Ihr Haus zum Smart Home. Somfy Smart Home macht Ihr Zuhause intelligent und Ihr Leben sicherer und komfortabler. So security and comfort is at the center. Per smartphone, tablet, PC, you deal with the total building technology. And they have different pieces, and that's where you can see the climatic differences. We have a smart home in Saudi Arabia, a smart home in Norway, smart home in Switzerland, smart home in Singapore. It will be very different in terms of what they use. So they have, for example, here, Switzerland, Heizung, the first thing, heating. Then the roofs on the windows in the roof, the handles of the windows, the door lock, the camera, also smoke detector, security sensors, alarm. There you have the Einfahrtstor, which is you driving in your garage, a garage door, different kinds of shutters opening, curtains, inner curtains like those, Fenstermarkise, another form of those, for terraces, Markise, to sun protection, exterior shading, and exterior rolling shades, and measuring the electricity, and then the electricity distribution, the light, and the weather sensors. So these are all, again, gadgets that you can all buy, and of course you're supposed to buy them, then your home becomes a smart home. Yes. And if you reduce it, this is the last one, don't worry. So here this goes just for a heating system. And this is even getting more interesting for cold climates like here. So in the view of these companies, now this is a company like the previous one, you have the heating system in the basement. And this is quite interesting because here, this is not a basement with a chimney or something anymore. It's just a basement. You see the architecture has almost totally disappeared. It's just a schematic. But in opposition to what even this school and most of your schools were teaching 30, 40 years ago, there was a chimney, there was a heating furnace, there was oil tanks, gas tanks, wood tanks, coal tanks, or whatever. This has all disappeared. So it's running on electricity. Of course, it's a heat pump. This heat pump is connected to a control system, which then wirelessly controls all the other possible things in the house that you can plug in remotely, wirelessly, to make your house more or less smart. And you decide what is smart. And then, of course, through this here, you are connected to the internet, and to the internet connection, you're connected to your smartphone, and you can do all kinds of things with your house while you are away. That must have a certain fascination. I never know why, but because if nobody's there, why do you do all these things? But it must be good. It must be fun. Yeah, there is more seats there. So this is a very realistic Anleitung almost to a smart home. Okay, we spent a little time on this because it's not so much different from smart cities. When we go now from smart houses to smart cities, it's interesting. You have almost the same technology. Most of the technology is very similar. So in smart houses, we listed those sequence of properties: convenience, security, control, performance, architecture, question mark. And for smart cities, when you read the advertisements or the announcements, and you will see more of those, you have a very strong point is always control. And then convenience, and then performance of the city, and then security. And urban design often also doesn't appear because it doesn't compute. So this is very, very interesting to see. The official or the definition of smart cities from Wikipedia, you can look it up yourself. But again, it starts immediately. A smart city, also a smarter city, uses digital technologies or information communication technologies to enhance quality and performance of urban services. So enhance quality of urban services, to reduce costs and resource consumption, and to engage more effectively and actively with its citizens. So the last point is important because that's the engagement with the citizens, is that what will lead us eventually to the responsive cities. That is the only part that leads to the responsive cities. And they give all kinds of examples and other words for these smart cities in the past were cyberville, digital city, electronic communities, flexi city, information city. This is that book that we wrote, intelligent city, knowledge-based city, mesh city, telecity, teletopia, ubiquitous city, wired city, all for the same. So in Korea, I remember the first ones were called ubiquitous happy cities. That's how they were labeled to express this definition. But there's more. It's a very real concept. This was theory, but now it's very real. Somebody from India here? No? That's unusual this year. So in India, the President Modi has a vision of developing 100 smart cities as satellite towns of larger cities and by modernizing the existing mid-sized cities. So in each one of the provinces and states, he wants to put in these smart cities. And he says, or the group that he's working with, had a completely different set of priorities for these smart cities. So adequate water supply, assured electricity supply, sanitation, efficient urban mobility, affordable housing, robust IT connectivity, good governance, very important, sustainable environment, safety and security, health and education. So that's a different set of definitions for the smart city. And you can see already, depending where you are, what you ask, you get different definitions. I want to go with not to go with definition, but I want to bring closer to you the definition that was developed here in Switzerland in a concerted effort of different Bundesämter, which like the ministries, which are not so much driven by commercial aspects, I would say, but who have a long-term vision of connecting energy cities to smart cities, to healthy cities, and other properties of cities. So in the next slides, we go through these different aspects of the smart city definition. And I gave it to you in summary last time. But let's look at the individual pieces. They say, and this is the source up there, a smart city offers its inhabitants, so it starts right away with the inhabitants, maximal life quality with minimal consumption of resources, based on an intelligent interconnection of infrastructure, transport, energy, communication, and so on different hierarchic levels, building, quarters, and cities. So that puts much more the person in the center. Yes?
Does it necessarily have to focus on inhabitants or also users of the city, such as people traveling through it or using it temporarily? That focuses on one user group a lot.
Very good. That's really amazing. You know, you hit one important point right away. This is going almost from a stable status of a city. You're absolutely right. A city which has a high number of transient people, like Shenzhen, for example, probably will have a different definition. But now this is a very good observation. But this is the way that this Swiss ministry describes how they see a city. Well, that's really very, very clear. And I put this image here because that's here from our campus. And this, of course, is what we wanted to do for our campus. We thought when we were designing this place and having the competitions for this place and so on, we had something in mind like that. It didn't exist, the word, yet. But we wanted that the people who are here have a maximum life quality with minimal consumption of resources. This is why we bring down the resources used by this campus, CO2 produced in this campus, to 0 by 2020. So this is why we have this maximum life quality, why we add places to sit and to eat. I mean, we're starting from a very low level, I agree, but to make it just more comfortable, as an example. Now, the second part is intelligent in this context. So smart, intelligent comes after smart. It does not necessarily equate information technology. Passive or self-regulating mechanisms are to be referred to actively controlled approaches when having similar performance. So here, I gave this example. Who knows that place? Have you been there? Zermatt? Yes. What's special about this? Huh? Toblerone. Okay. Huh? It's not car-free. Yeah. I've never seen another city which is totally running on electric cars, and since 20, 30 years, and nobody's talking about it. But that means, I think it's a good example for having some semi-passive devices. By just eliminating a car with an engine, with a combustion engine, you eliminate all kinds of problems and regulations you would have to have if you had those cars in that city. So this is an example, just one example. Objections? Not yet. Okay, so another part of definition is that smart city is no new label. That's important because, for example, a building gets a LEED label, a LEED standard label, or it gets in Switzerland a Minergie standard label. So smart city is not a label, but describes a deepening engagement for the expansion of existing activities and projects of an innovative city possessing the European Energy Award. Well, this is getting very specific now, but this European Energy Award is a Europe-wide competition that you make your city ready for a smart city to achieve those goals that they set in the beginning. And that offers the new possibilities for support of their innovative and smart projects on the way to achieving the ambitious goals. So that means empowering the individual members of those cities and villages to do their part for the smart city. So this is an example of an installation of such energy collecting devices on roofs, and this is how it normally starts. Now let's look at some characteristics of a smart city. And this is now the how. How do we do that? How would we develop that? It systematically applies information and communication technology, IT, this is what we all do, that's nothing new, as well as technology conserving resources on its way to post-fossil society. So this is a very political thing, of course, post-fossil society. But it could mean anything. It could be nuclear society, it could be solar society, whatever, but just post-fossil, because in Switzerland, this was really identified as the major problem that cities are producing today, which is the 80% of the CO2 in the world. And therefore, this post-fossil society is important. And it tends to become independent of fossil energy carriers on the long run. I put this image here of the sun from the library of Professor Werner Oechslin, our colleague here at ETH, where all these things were described in his library, how you make the energy and all these nice things, the security, the control, and so on, without fossil energy, because at this time it wasn't even known. So it was the pre-fossil and the post-fossil might be quite related. Then the smart city connects new technologies for infrastructure, buildings, mobility, and so on, to use resources such as energy or water as efficiently as possible, and anticipates and realizes future sustainable forms of mobility and the necessary infrastructure. That is, of course, in Zurich, if you look around, the trams and so on are very, very efficient, I think. And, but with this picture here, I want to show that also this efficient means of transportation can disappear suddenly for other reasons. Do you know a big city, more than 15 million people, where the trams have disappeared at the beginning of the 20th century already? They had trams. Huge tram network just disappeared. Yeah?
Los Angeles?
Los Angeles, yeah, was one. And this one, believe it or not, I was looking through the archives of ETH and I found this old postcard. Somebody had sent it from Singapore in 1906. And in 1906, they had an electric tramway power station. They had made extra a power station to make electricity for the electric tramways, for this very efficient mode of transportation. It doesn't exist anymore. So at this time, Singapore was tiny, had trams. Today it's huge, it has no trams. It could desperately need trams or electric transportation. So there's no guarantee that even if you have done it once, that it will stay, it can disappear. So this is part of the smartness, I think, as well. The smart city forces integrated city planning processes for energy planning, for example, and it creates spaces for innovation and the testing of new ideas. And again, I put something that might look old, but is new, because even the use of wood and the combination of wood and concrete and high-tech is no contradiction. So you can make very, very attractive new spaces, like here in the TA Media in Zurich by Shibero Ban, and make these kind of smart places with it. And finally, the smart city characterizes that it installs management systems, good governance. Do you know this image here, where it is? Have you been there? No? So whenever you go to Siena in Italy, in Siena you go into the main square, the Campo, and there you go into the Rathaus, into the city hall, and in the city hall, in a place with very not so nice light, very dim light, you find this picture, and this describes the good governance and the bad governance. Anyway, this is the good governance, and you go there or look it up and you will see why. So the good governance to enable optimized leadership in the different areas and through holistic controlling for developments to be reported in a measurable and verifiable manner. So the measurable and verifiable is important. And it provides the appropriate personal and financial resources and the integration and interconnection of these areas in the characteristic of a smart city with the aim of realizing the potential for ecological and social improvements. So if you do that, then everything will be fine. Now, now it's getting very hot. A smart room now would do what? It would open the window for a short time, maybe, just 1 minute. But a smart city would also do something else. A smart city would listen or would record the noise. And it would record that every 3 or 4 minutes there is an incredible noise happening down there, which is? Now it's a horse. This is not incredible. No, it's the buses. When the buses go by, it goes like, whoom, and you just cannot concentrate. No, this is the post-fossil society. But the fossil buses, they go by and they make a huge noise every few minutes. And we know there's a solution to that. Yet a smart city would give that feedback to the people who decide which kind of buses are driving here. And eventually, hopefully, they would disappear, and the noiseless electric buses would just zoom through here, which would make it much more comfortable to work. So that example obviously did not work, but I think you know what I mean. This is what we had last time, the very big attack on the smart cities. This is your argument, basically, you know. The giants of the technology industry, smart cities are fixes for the dumb designs of the last century, which is an insult because the designs were not dumb. They were just made for another time for different purposes. And so you cannot just say they were dumb and we make them smart. So this is what you have to remember. And a new industrial revolution to deal with the unintended consequences of the first one. And so on. So this is from the book that I mentioned. And there is a lot of criticism, of course, in smart cities already in different places, especially in Germany. Germans always are very critical, as you know, and they mock themselves about was für eine Utopie, what an utopia. The sensors are registering every activity of the people. The cameras have everything in their view. that moves in the city. Who of you has seen the Minority Report? Yeah, see, the others are so young, they don't even, that's just 10, 12 years old. But basically, that's what they're all afraid of. This, when you look at the movie Minority Report, you know that everything is recorded, observed, stored. And then, yes, maybe some good things might happen for you, but on the other side, the control is just taking over totally. And this is what this article is attacking. And then there are things in between. This is quite interesting. This is from the BBC. Having a feature on the future of cities, already call it responsive cities, and it starts with a thing. As the city unwinds into the evening, so you would expect something, people relax and go home. No. Indoor sensors adjust the ambient temperature and turn lights on. Televisions, radios, and even baths are operated with a gesture from an armchair. So this is how, this is seen as the responsive city. And then in the rush hour in the city, people make their way home after a hard day's work. Driverless cars pass by as cyclists steam along purpose-built lanes, safe from motorized traffic and unpredictable pedestrians. Another vision. And then here, in the end, finally, of course, architecture, infrastructure, and planning are important, but at the heart of all cities are communities and people. If the urban future needs to be sustainable, it needs to work much more closely with its inhabitants. So that's the conclusion they have. Good. I think you got enough examples. Just one very practical example. Last week, after our lecture, 2 days later, I received an email from my co-worker in Singapore. Actually, she's the HR manager for our Future Cities Laboratory in Singapore, and she writes, dear all, to our Future Cities Lab, HR, Human Resources, had been monitoring the PSI level. Do you know what that is, PSI level? No? It's not the Paul Scherrer Institute. It's, it's the, yeah, we'll see. And at this moment, it is in the hazardous level at 314 PSI for 3 hours reading. It comes to our attention on the safety of our employees, and if it continues to worsen, please take extra measure to limit your outdoor activities. For those who are feeling unwell tomorrow, you may work from home, but please do update Human Resources of your absence from the office. There are still masks available, and you may collect from Human Resources if you need it. Take care, everyone, and thank you. Best regards, Pfizer. So this is what a smart device could do in the best possible case. It's a human being. She's caring for the other people in the office, and she gives them this advice. What is in the background? And this is now from monitors, from sensors in the city. This is the island of Singapore, and you can see here the different colors and different numbers. These express the PSI level, how many parts per million are in a cubic meter of air of hazardous materials. And you can see here 224, it's quite high, and obviously it became even higher to 314, and then it's very healthy and unhazardous. So this is, I would say, a good example of feedback from sensors to people to show what's going on in the city. If you were in the old days, you would have no clue why you're coughing and why you're falling down. And then not only this, you also get the reason for that. You see the haze on the left side, and you see this one here. If those of you who know Southeast Asia, there's Singapore and this little spot. Things here, do you have an idea what those are? Those dark ones? Fires, yes. And they're forest, not necessarily forest fires. Normally they're shrubs and other parts are being burned to prepare the land for more of all kinds of oil palms normally and other higher value crops than what they think they have. And so this is where the smog comes from. It's drawing over there. And so you get quite some intelligence, not only from this, not from the very local, from the HR manager, goes to the city, which shows you where it's hazardous and where it's better, so you might want to go there. To the look on the real-time feed from the camera there with the haze, and even the reason which is outside of the country. So I think this is a good example for the development towards a smart city. Of course, the actions you must take are quite different. Okay, so let's finally come to the exercise. We have 3 exercises. By the way, this is also across Singapore, and you can imagine how this thing gets there, this huge mountain of clouds. The first exercise is about examples of smart cities, and you will get this text. We will send it to you in PDF, so you don't have to write it down. But it's important that you understand and make your own interpretation of the concept of smart cities, and more important, to have a relevant definition of smart cities for architecture and urban planning, for the disciplines that you are coming from, okay? Because there is no standard definition, and it's important to make one for each one of your disciplines where you are coming from. 3 weeks from now, we will put them all together, discuss them here in class, look at the different outcomes of that, and I think that will be very, very interesting. So there are 3 parts of the exercise. First, you describe in your own words a definition for smart cities. Then you make a list of at least 5 predominant features of smart cities, and the most important at the top, of course. Then you research some examples of smart cities. Make again a list of 5 to 10 cities. You pick, what you think are smart cities, and then look at them if they fulfill the criteria you set in the first place. There might be differences. Then you can rework the first part if you want. And in part 3, you select one of the cities in part 2, just one, and which is of particular interest to you. And then you highlight and further describe 2 to 3 features which make it smart. Remember, it doesn't have to be active elements. It can be passive elements. It can be good governance. It can be all kinds of other elements, okay? It doesn't have to be technology only. It can be a combination of technology, but also a combination of technology and good governance and other features. But you figure them out. And then you include references and data sources where you found this. When you have some wild statements, put it in and send it in PowerPoint format. Free, you can make any PowerPoint slide as you wish, and send it until October 8 to Daniel Gregor. That's her address there. And if you feel uncomfortable with this, just not enough information, I'll also listed some reading material for you in addition, which is focusing on smart cities. And this chapter 1, chapter 3 gives a very detailed description, but they're very technologically oriented, okay? Some of you might come more from another angle, so don't think you have to squeeze everything into the technological side. We really want to get a good definition for cities from the whole width of your backgrounds. That's a exam, first exercise. Let me come to the summary, and this is maybe abstract again, but I think it's easy to understand. Smart rooms, smart homes, and smart buildings are building blocks of smart cities. So they're all building blocks, but it doesn't mean that you can just scale them up. So scaling up from a smart room to a smart house, to a smart neighborhood, to a smart city, to a smart territory is not an additive or linear process. You cannot just add it up. It doesn't make it smarter. Because the complexity of interaction between those parts increases exponentially. And you will see that already, even if you look at one room, from one room to one house. But we want to understand the functioning, and therefore the opportunities and the threats of the smart city. And if we want to do that, we must focus on the goals of this smart city and on the interactions and the components of smart cities. And that is exactly what you hopefully will be able to do in exercise 1. Have any questions to that? Yes?
I see the potential of smart cities and smart houses and connecting to each other. And I see that. But the question of privacy, I think, it's very important because with the smartphones and then living in a smart house and then in a smart city, everything, all the data is collected, what everyone is doing at any time. So there is also, like this point of view, I think is also important to describe it, or what can be done against this problem.
Absolutely, yeah. And do it. Because that might be, the walls that you had to protect against fire and bad people. You might need different walls to protect against this invasion of privacy from the data side. We already have all these names, the firewalls and these kind of things, but maybe that's not enough. So describe it. Maybe then your smart city is a completely different one from her or from his. So describe it.
With the technology today, it is very difficult to find a solution for this problem. It's nearly impossible, I think.
But maybe, as inventors of inventing something good in the future, somebody comes up with a good idea. I'm sure you will. I'm sure you will. But yeah, on the other hand, we cannot just say we shouldn't do it. It's too late, it's already there. So I think it's our duty to make it work in a way that it's for the benefit of the future inhabitants. And that's what we have to think about. All right, more questions? Anyway, I'm here. You can come to my office anytime, and it's open. This afternoon, we give a fantastic presentation to the city of Zurich, which is using some of the instruments that you will learn during the course in practice. So we're presenting the possibility of making a bridge across the train tracks in Zurich and to revitalize a whole or two parts of the city by doing this, not by doing a bridge, by doing something on the bridge. And this is done exactly from what I showed in the beginning, using all the evidence that we have, all the data we have, but then also designing something in the future which is not there yet, and then using simulation to get there. So I'm curious if it will work. I'll let you know next time. So with this, have a beautiful afternoon. Thank you very much. See you.